In addition to the power rule, we're also going to take a look at some of the basic derivative rules. We're going to look at the constant multiple of a function and the sum and difference of two functions. So these are the easiest rules because they're kind of what you would expect. The derivative of a constant multiple of a function is just a constant multiple times the derivative. All right. The derivative of the sum is the sum of the derivatives, and the derivative of a difference is just the difference of the derivatives. All right. So those are nice and straightforward. So let's take a look at how we can use those. All right, these first two examples are just constant multiples. So essentially what we have in this first function is just 3 times a power function, x to the fourth. So remember that the derivative of the constant multiple of a function is just the constant multiple times the derivative, right? So we're just going to, all right, f prime of x, we're just going to keep that 3, and then we're going to take the derivative of x to the fourth, right? So bring down the power and then subtract 1. All right, so let's clean that up a little bit. We can write just 12x cubed. All right, so just keep the constant multiple around, and be careful too, because I've seen people, they see, oh, the derivative of 3 is 0. The derivative of x to the fourth is 4x cubed, and then 0 times 4x cubed is equal to 0. No, that's not that's not the way it works, all right? Because the derivative of a product is not the product of the derivatives. We're going to get into the product rule later on, right? It only works for sums and differences, where the derivative of a sum is the sum of the derivatives, and the derivative of a difference is the difference of the derivatives. It doesn't work with products. So, so if you have a constant multiple times a function, you just take that constant multiple times the derivative of the function. All right. All right, let's take a look at this one. We need to rewrite it first, right? So this is equal to 1/5 times x to the minus 2. I'm going to rewrite that 1 over x squared as x to the minus 2. Now it looks like a power function. So I have a constant multiple times a power function. So I can write that g prime of x is equal to 1/5 oops, not 1/2, 1/5 times, we bring down that minus 2, so it's times minus 2. So put it in parentheses so it doesn't look like you're subtracting 2. And then x to the minus 3. Now I can clean that up, or you might just go straight to writing it this way in the first place. You got negative 2 fifths x to the minus 3. All right. All right, these next two examples are just sums and differences. The first one is just a sum, so we're going to find the derivative just by taking the derivative of each part of this function. All right, so you can think of this as being two functions added together. We have 3 to the x added to 8. And so we just take the derivative, the derivative is going to be the sum of these derivatives. So the derivative of 3x is 3, and the derivative of 8 is 0. So the derivative of this p of x is just 3. All right, so here we also have a sum. So we're going to write the derivative, and we're just going to take the derivative of each part, right? And so the derivative of x squared is 2x. The derivative of 5x is just 5. And then we have the derivative of negative 12, which is just 0. All right, so the derivative is just 2x plus 5. All right, got a couple more here. Now sometimes we have to rewrite these. So I'm going to rewrite this as 2/3. Whoops, not 1/3. So I'm going to have 2 square root of x over 3 plus 4 over 3, right? Just, it can think of that as being 1/3 times that whole quantity in the numerator. All right, so the coefficient on the square root of x is 2/3. And then this is x to the 1/2 plus 4/3. Okay, so at this point, all I have done is rewrite the original function. I haven't taken any derivatives yet. I'm just rewriting it so that it looks more like a power function. Here we have a constant multiple times a power function, and then we have just a constant. Oops, and that should have been a third. Should have been a 3 in the denominator there. All right, now I'm going to take the derivative. H prime of x is equal to, I'm going to have that constant multiple. Whoops, why do I keep writing 1? 2/3, and then times, I'm going to bring down the 1/2, and then subtract 1/2 from the exponent. So I'm going to negative 1/2, and then the derivative of 4/3 is 0, right? So I can clean this up a little bit because I can basically cancel the 2's, and I'll get 1/3 x to the minus 1/2. Or you could write it as 1/3 times the square root of x, right? Where 3 times the square root of x would be in the denominator. But this is fine. All right, so this one again, I need to rewrite it. This is x to the 1 times x to the 1/2, right? So I've got a product with the same base, so I just need to rewrite this as x to the 3/2, right? Just 1 plus a half. Right, I'm just adding the exponents on these two things. And then minus 2x to the minus 1. Right, so I'm just rewriting this as the sum of, or difference in this case, of power functions. And now I can find the derivative. So I'm going to write dy dx, right, because this is a different function. And I'm just going to bring down the 3/2 and then subtract 1, so x to the 1/2. And then I'm going to bring down that minus 1, so this becomes a positive 2. And then x to the minus 1 is minus 2. Okay? So there you go. There's some examples of how to use those basic derivative rules. Now, again, like I said before, I mentioned this before, the derivative of a product is not the product of the derivatives, and the derivative of a quotient is not the quotient of derivatives. This is important. We're going to learn these soon. We're going to learn how to take the derivative of a product and how to take the derivative of a quotient. But it's not nice and straightforward like a sum and a difference. All right, so be careful about that. You can't just take the product of the derivatives when you take the derivative of a product. Okay. All right. Well, that's all I have for you, and you can go ahead and work on the discussion questions.